Alright, welcome back from spring break, guys. I hope you had a restful spring break. I want to pick up the worksheets where we left off the week before spring break. And I'm going to talk kind of fast, so this video is not very long, but feel free to pause, rewind, and watch it again. So that's why I'm talking so fast, so we can finish the worksheet in a timely manner. We ended the class the week before spring break with solar eclipse, and we had this drawing in our notes. And it's solar eclipse because the sun is being blocked. Solar eclipse because the sun is being blocked, and lunar eclipse, which we're going to talk about in a minute, is when the moon, or luna, is being blocked. So we have this drawing, the sun, the moon, and the earth. The moon is blocking the sun from being seen on the earth. And we have these definitions, which I want to make sure that you have in your notes. These shadows on the side of the moon are partial shadows, and they are called penumbras. P-E-N-U-M-B-R-A, penumbra. And the full shadow in the middle, where the two shadows converge and have a very dark spot on the earth, the full shadow is called umbra, U-M-B-R-A. So make sure you have your solar eclipse drawing done in your notes with the shadow lines, the dark shadow in the middle, the two partial shadows on the side. And from here we have to move on to lunar eclipse. So here are the notes for lunar eclipse. A lunar eclipse is when the moon is blocked by the shadow of the earth because the moon is now behind the earth. Okay, the moon is behind the earth. Therefore, it's a lunar eclipse. The moon, luna, is being blocked. This orbital path puts it into the shadow of the earth. This happens during the phase of the moon when it's a full moon. So remember we did that experiment with the tennis ball behind our heads, full moon, it's receiving all this sunlight and the moon is really bright, and then all of a sudden it comes into the shadow of the earth. And the earth is in the middle in this diagram. So let's draw it in our notes. This is what it looks like, that as the moon, your full moon, comes into the shadow of the earth, it gets a little bit darker and it becomes this blood red moon because it's the light as it wraps around the earth goes through our atmosphere and changes color from white light to red, and it projects this red onto the surface of the moon. Alright, here's your lunar eclipse drawing in your notes. Again, 4 lines. Start at the sun, go to the top and bottom of the earth. Start at the bottom of the sun, go to the top and bottom of the earth. So you probably want to pause it here and get those 4 lines done. At this point you can do your partial and full shadows. So in here you're going to have your partial shadow. So I'm going to do a hash shading. In here, partial shadow, a hash shading. Alright, those are your partial shadows, so let's write that in. And what is that called? Penumbra. Two penumbras. And then the full shadow in the middle, so this has got to be all colored in here. Half the earth is in nighttime, so that also gets shaded in. So this gets all shaded in here. That full shadow is called umbra. U-M-B-R-A, umbra. So go ahead and get your drawing done in your notes for the lunar eclipse when luna is being blocked by the shadow of the earth. In summary, here are both the solar eclipse and the lunar eclipse being shown on this drawing. Solar means sun is being blocked. Lunar means moon is being blocked. We looked at this video in class about why this only happens during some full and new moons because of the 5-degree tilt that the moon's orbit is on. So in some cases the moon is too high for lunar eclipses. And in some cases the moon is too low for lunar and solar eclipses. But at other times the moon is in the right orbital plane for lunar and solar eclipses to occur. So you'll notice at the bottom of your worksheet I ask you, why does in every new moon and full moon a lunar or solar eclipse occur? It's because of this 5-degree tilt. So answer that on your worksheet. All right, flip over your worksheet. We're on the back side now with the new information called tides. You probably also want to put this in your vocabulary summary sheet that I gave you with that big chart. There's also a section for tides. Now maybe you've seen this in pictures or you've even experienced it in a lake where the water level can rise and fall. Why do water levels rise and fall? It's because the gravity of the moon is pulling on the earth and pulling on the earth's waters. So in your worksheet I ask you to draw and label the demonstration. So here's my trusty hula hoop that again were used for the moon's orbit. So here's my demo. That if my body, my head is the earth, this is the earth's waters now, right? I'm not talking about moon anymore, I'm talking about earth's water. So imagine this is the earth's waters. That if the moon, which is, let's say, is out here, and the moon is going to pull on the earth and our waters just a little bit, what happens is it pulls, and it pulls that water, and what happens to the sides? The sides come in. So this, where the moon pulled the earth's waters, would be high tide. And here, the sides that come in would be considered low tide. And what happens behind me? Also high tide. So you got two low tides, two places on the earth are experiencing low tides, and two places on earth, front and behind, are considered high tides. So the moon influences the water on earth, and also the earth moves a little bit towards the moon as well, okay? So draw that and label that demonstration in your notes. But here's a better one. Here's a better one on this screen. Here's your moon. Here's the earth. The moon is gently pulling the waters of the earth towards it. That brings the waters on these sides of the earth in, and the water on the other side opposite the moon out. So at any point in a day, there are two places on the earth experiencing high tides and two places on the earth experiencing low tides. So the high tides will be on the side of the earth that are facing the moon and the exact opposite side of the earth. And the low tides are the two places in between those two high tides, so on the two faces that are opposite to the earth. So you might want to pause it here to make sure you got all the notes about high and low tides. Here's a little animation to show what's happening. That as the moon rotates or revolves around the earth, the moon pulls on the earth's waters, giving you high tides at every place that the moon is. But this is not what really happens. We know that the moon goes around the earth in 27 or 28 days. But the earth's rotation takes 24 hours, so this is much, much faster. What happens is that in our 24-hour day, we're going to interact with the moon 4 different ways. We're going to start by interacting with the moon on a high tide, then here we'll be on a low tide, then here we'll be on a high tide again, here we'll be on a low tide again, and here we will be back to high tide. So, start with a high tide, then we go to a low tide, we go back in 12 hours to a high tide, 18 hours a low tide, and back in a full day to a high tide. So in a 24-hour period, you're going to have 2 high tides and 2 low tides. Because this process of the moon going around the earth, the revolution takes 28 days, but this rotation is much, much faster in 24 hours. So in that 24-hour period, you'll have 2 of the one tide and 2 of the other tide. Here's another little quick animation, really sped up, that will show. So there's the rest of your worksheet that you can fill out. Draw and label the demonstration. How does the moon influence the water and on the earth? Here's a diagram that I want you to answer, and then a summary question for you to finish the discussion about tides. All right, just so we've now finished lunar phases, eclipses, and tides, and that completes this worksheet. Fill out, turn it in, every question, and we'll now move on to the next topic, which is scientific notation. All right, thanks for listening, guys. Welcome back from spring break.